Density is a property that we're going to talk about quite a bit in class, and it's going to be revisited throughout the year. And density is, by definition, how compact the molecules are in a substance. So you've seen the word compactness to describe density. And to find density, we're going to need the mass and the volume of a substance. We talk about mass and volume as a ratio, and we're going to look at that in a minute. So you have to remember D equals M over V. Density equals mass over volume. And it's very important to realize that density does not depend on the sample size. In class, we're going to do the chocolate bar lab, which we're actually going to look at the fact that we can change the size of the chocolate bar, but the density of the chocolate never changes. So the first question is, what happens to the density of a uniform block if it is cut in half? So uniform being it's the same throughout. And I have this wooden block and I cut it in half. There's no change to the composition of the block. It's still the same wood. I haven't, changed the state of matter, and it's the same. The only difference is now that this block is going to have half the mass that it did originally, but it's also going to take up less volume. So it's going to have that same mass to volume ratio, hence no change in the density. So now let's look at something like this. So what happens to the density of the air inside the balloon as we heat it? We're talking about a hot air balloon. And we have to think about, well, a hot air balloon is going to rise off the ground. That's what we want it to do. We want it to float. And as we heat the air in the balloon, what's going to happen is we're going to have some phase changes. And we're going to think about, I want you to think about those phase changes that you've learned about, that we go from solid to liquid to gas. Again, solid, the molecules are going to be very, very compact. Okay, they don't move very quickly. Then the liquid state of matter, the molecules can move a little bit more and they move a little further away from each other. And in a gas, the molecules are going to move very fast and they're going to bounce off each other and they are going to spread farther and farther apart. So as we're increasing temperature, this is what we're doing to the air in there. We're actually moving it, so that we're increasing that average kinetic energy. Well, what happens is when we do that, and we have to talk about volume as well, the molecules are going to move farther apart. So they become less compact and the density is going to decrease. The volume, though, is going to increase because the molecules are taking up more room because they're bouncing away from each other. They're filling up that whole space because of the change in average kinetic energy. They're going to get warmer and they're going to move faster. If we cool the air, the opposite happens. So now the molecules are going to slow down and they're going to come closer together. They become more compact. Density is how compact a substance is. So it's going to become more compact, which is going to increase the density when we cool the air. And then there's this question, what has the greater density, ice or water? And what observation supports your answer? Well, let's take a look at some examples. Here we've got some ice floating on the ocean, glaciers, icebergs. We think of those things. And we want to know, well, solids normally sink in the liquid, but not ice. If you put ice in your drink, the ice cubes float to the top. Well, why? If ice is solid water, why does it float? And it has to do with the fact that, water has a higher density as a liquid than it does as a solid because of the way the bonds form when ice forms. There's weak hydrogen bonds that form between the molecules of water, and that creates space between those molecules. That space allows the molecules to have some space between them, which makes them less compact than they are when they're in a liquid state. Less compact means less dense. So ice is going to float on water because in the solid form it's actually going to be less compact because of those bonds and the way they form than it is when it's a liquid. So we look at some graphical representation. We want to look at density versus temperature, which we were talking about a little bit. Temperature is the independent variable here. As the temperature is increasing, we can see that density is actually going to decrease. Okay, so we've got that inverse relationship going on. So temperature, as it increases, density is going to decrease. But if we're talking about pressure, and we go back to pressure, Remember the example I used with the clay. You're pushing on that clay and you're pushing all those molecules closer and closer together. You're actually going to increase the density because you're making the molecules more compact. So here we can see pressure is on the x-axis. As pressure is going to increase, so does density. Okay, so we have that direct relationship. Remember a couple of things, water has a maximum density as a liquid. That's going to be your exception because most solids are going to have a density that is greater in solid form than it is if it's in liquid form. All right, so these relationships you must remember. Remember that density talks about compactness of molecules. So when there's more pressure, it's going to make the molecules more compact, and that compactness is going to increase density.